my dear students. I welcome you all in chemistry class. Today I am going to take next chapter of the chemistry, that is electrochemistry. Well students, before starting the electrochemistry, let us recall redox reactions. We studied about redox reactions in class 11th. And according to that, a redox reaction is a reaction which involves both reduction and oxidation. In other words, we can say that if both oxidation and reduction takes place simultaneously during a chemical reaction, then it is called as a redox reaction. Now, the question is that what is oxidation and reduction? And according to the classical concept, oxidation is the addition of oxygen or removal of hydrogen, and reduction is the removal of oxygen or addition of hydrogen. But the most important definition of oxidation and reduction which is used in this chapter is according to the electronic concept of redox reaction. And according to that, oxidation is a reaction which involves loss of electron, and reduction is a reaction which involves the gain of electron. Okay? And the substance which get reduced and oxidize the other substance, then it is called oxidizing agent, while the substance which get oxidized and reduce the other substance, then it is called reducing agent. Or simply we can say that oxidizing agent is a substance which gain electrons, while reducing agent is a substance which loses the electrons. And a redox reaction may be considered to be made up of two half cell reactions, one involving oxidation and other involving reduction. I hope up to this point it is clear to all of you. Now let's start with the term electrochemistry. What is electrochemistry? Electrochemistry is defined as that branch of physical chemistry which deals with the relationship between electrical energy and chemical changes taking place in a redox reactions. Or simply we can say that how chemical energy produced in a redox reaction can be converted into electrical energy, or how electrical energy can be used to bring about a redox reaction which is otherwise a non-spontaneous process. Therefore, in electrochemistry, we study electrochemical changes which are defined as chemical changes involving transport of electrons accompanied by the flow of electric current. Electrochemistry is broadly divided into two categories, namely prediction of chemical changes by electrical energy, and this phenomena is called as electrolysis, and conversion of chemical energy into electrical energy, that is production of electricity by spontaneous redox reactions. And in this unit both these aspects will be described. All electrochemical reactions involve transfer of electrons and are therefore oxidation reduction reactions, or simply we can say that they are redox reactions. Now let's move to the electrolytic cell and electrolysis. Electrolysis may be defined as a process of decomposition of an electrolyte by the passage of electricity through its aqueous solution or molten state. In other words, we can say that chemical change occurring at electrodes when electric current is passed through electrolytic solution is called electrolysis. And the apparatus used to bring about electrolysis is called electrolytic cell. It consists of a glass vessel in which the electrolyte in the form of an aqueous solution or in the molten state is taken. Two metal rods are dipped into it and are connected to a source of electricity, that is battery. These rods are called electrodes. The one connected to the negative pole of the battery is called cathode and the other connected to the positive pole of the battery is called anode. And students, always remember that oxidation occurs at anode and reduction takes place at the cathode. And students, whenever an electrolyte is dissolved in water or taken in the molten state, the electrolyte dissociates to produce positively charged and negatively charged ions. And on passing electric current, the oppositely charged ions move towards the oppositely charged electrodes as opposite charges attract each other. So, positively charged ions move towards the cathode, hence are called cations, whereas negatively charged ions move towards anode, hence are called anions. On reaching their respective electrodes, ions lose their charge and become neutral species. Cations accept electrons from the cathode to become neutral species, whereas anions give electrons to the anode to become neutral species. Thus, oxidation occurs at anode while reduction takes place at the cathode, and the conversion of ions into the neutral species at their respective electrode is called primary change, and the product formed as a result of primary change may be collected as such or it may undergo a secondary change to form the final product. Okay students? Now let us take an example to better understand this concept. Electrolysis of molten sodium chloride. Molten sodium chloride contains Na positive and Cl negative ions. On passing electricity, Na positive ions move towards cathode while Cl negative ions move towards anode. On reaching the cathode, each Na positive ion picks up an electron from the cathode and becomes a neutral atom. Thus, sodium metal is liberated at the cathode. And on reaching the anode, each Cl negative ion gives an electron to the anode and becomes a neutral chlorine atom. Since chlorine atoms are unstable, therefore, two atoms of chlorine combines to form chlorine molecule. Thus, Cl2 gas is evolved at anode. Thank you students and have a nice day.